Voxtral is a series of leading open source models for transcription. There are two kinds right now. There's a real-time type for word-by-word transcription, and there's also a batch type, which is now a little bit older from late in 2025. I'm going to describe the pros and cons of these models and compare them to Whisper. I'll also describe how to train these models, and I'll talk a little bit about how you can inference them using vLLM. This will be particularly useful for those of you who want to run transcription models on device. Now, these models are not very, very small, so probably not recommended for a phone or maybe even iPad. But if you want to run them on a GPU, or if you want to run them on your computer, say you have a Mac with more power, then these models are going to perform pretty well. So I'm going to go back and start with the release of Voxtral itself, which was late in 2025, well, July 15, 2025. This is a batch transcription model. And when it was released, it outperformed a lot of the proprietary models of the time, except for Scribe from 11 Labs. Now, 11 Labs have since released Scribe V2, which is even better than this. But you can see the word error rate on Voxtral here, Voxtral Small or Mini or Mini Transcribe or Mini. It's kind of better than some of the other proprietary models that were out at the time. So Voxtral is basically a very good transcription model, particularly multilingual. It looks a bit better than it actually is on Whisper. Whisper is way up here, but that's because Whisper is very strong on English and it is weaker on other non-English languages. So while it looks like the Voxtral models outperform Whisper by a lot here, that's because it's being measured on FLIR, which is a multilingual dataset. And so actually Whisper is probably better for English, but for the other languages, Voxtral is better. Now, it's confusing to follow all the Voxtral models because there's Voxtral Real-Time, which is the more recent one. And then there are various versions of Voxtral and Real-Time. There's Voxtral Small, Mini Transcribe, and Mini. Voxtral Small is not actually that small. It's based on Whisper, or it's based rather on MiniStral Small, which is a 24 billion parameter model. So it's very large, probably too large for a transcription model. Voxtral Mini is based on MiniStral, which is a 4 billion-ish parameter model. So that's quite a bit smaller, but still more than twice the size of Whisper Large Turbo. And then Voxtral Mini Transcribe is a proprietary model, not OpenWeights. It's a fine-tune of Voxtral Mini specifically for transcription, because in principle, Voxtral are not just transcription models. They're actually voice plus text input and text output. That's what a Voxtral model is. And of course, if you can allow voice and text input, you can also just allow voice input, in which case it becomes a transcription model. And if you tune it just for that, you improve the model primarily just because the formatting is improved. So I'll show you this in a more clear table. Now, to add further confusion to the matter, there is the Voxtral Real-Time series of models that has been released. And actually this release has got two models, one of which is a real-time model and is OpenWeights, and the other one is Voxtral Mini Transcribe V2, which I understand is basically a better version of this Voxtral Mini model, which was proprietary, and the Voxtral Mini Transcribe 2 model is also proprietary, probably performs a little bit better, but the V2 also provides diarization and I believe timestamping as well, although I think this provides timestamping on the API too. So Voxtral Mini Transcribe and Transcribe V2 you can only get available via API from MiniStral, whereas Voxtral Mini, Voxtral Small, and Voxtral Real-Time, which is a streaming model, are available OpenWeights. Now, if you look at the performance, you can see that Voxtral Mini Transcribe, it's still not, well, this is diarization actually, so this is not even available OpenWeights, but just as a comparison, MiniStral's leading model is not quite as good as Scribe V2 here, but it's better than some of, say, DeepGram Assembly and Gemini's 2.5 Flash model. And if you look at transcription performance, it's really not far off of Scribe V2, but it's better than some of the other larger labs. And then if we look at real-time, okay, here's real-time. And yeah, so the real-time is shown here actually in the colored, and it actually is quite close to where you go on the Voxtral Mini Transcribe V2. But as you have more of a delay, so if you transcribe with half a second versus 2.5 seconds of delay from the speaker, you're going to get better or worse accuracy. Worse accuracy as you've got smaller delay. If you've more delay, then the model has more context, so it's going to do better. And you can see the model does well across a variety of languages, and it kind of asymptotes down as you make a very large delay of 2.5 seconds to the performance of the Voxtral Mini Transcribe. So I suppose when you look at these graphs of performance on transcription, you can kind of consider that the real-time model is somewhere slightly above Voxtral Mini Transcribe. So it's not far off Scribe, and it's better than some of these proprietary models here. Now I've put together a little table that we can check out to compare some of these. I'll say it once more because it all gets confusing. You can check this out, research.trelis.com/STT for speech to text. Probably should have called that ASR. So we have Voxtral Mini Transcribe, Voxtral Real-Time, similar word error rate, Voxtral Small, Voxtral Mini Transcribe, that's the V1. So you can see the improvement down to V2, and then Voxtral Mini, which is the 3B open source model. And you can see these outperform Whisper, but that's primarily because Whisper performs best on English, and this metric for FLIR is measured across different families. And then here we have some of the proprietary performances. Now, in terms of fine-tuning support, which I'll get onto now, you can, of course, fine-tune Whisper, all the Whisper ones, tiny, base, small, medium, large, or turbo. You can fine-tune them with unslot or transformers. Voxtral Mini, you can also tune with transformers, but not yet with unslot. There's a pull request that is, well, I'm not sure if it's even a pull request yet, but there's a branch about integrating that. You can train it using scripts within advanced audio. If you go to trelis.com and purchase lifetime access there, you can also train it on Trelis Studio, which is the Trelis training platform, and I'll briefly show you that. Voxtral Small, you can actually train that. I think if I refresh the page, yeah, that's fixed. You can actually train that on advanced audio using the scripts in the repo I'll share. That's a paid lifetime access. And Voxtral Real-Time, there's no transformer support yet for fine-tuning. It's only supporting inference, but that support will be coming soon. I should have pending written there. And when that's supported, Trelis Studio and the advanced audio repo will support that. And just one more model down here. I haven't made a video about it for fine-tuning, but the advanced audio repo does include custom scripts for the data prep and also to do the training of a QTI speech-to-text model. And that they're included. I'm not going to go over them today. There's quite a lot that you have to say there to tune a streaming model around the data preparation. I might get around to a video at some point in the future. So yeah, you can check out this page if you want to take a look for yourself at the comparisons. Now, I do want to quickly show a few things about how these models work. This is the abstract and the paper for Voxtral. And it's useful to look at this schematic diagram here. So if you look at Whisper, Whisper is an encoder-decoder architecture. It encodes the audio and then it decodes. And Voxtral is similar. It actually uses the audio encoder from Whisper. So it uses the encoder here. It's the Whisper encoder. And for the decoder, it uses MiniStral. So Voxtral actually has the same limitations as Whisper in that it requires 30-second input audio chunks. And if your audio is shorter, you have to pad it out to the full 30 seconds, which means you need to use more flops and more energy consumption and more power if it's a small device. So this is kind of a drawback, although they get rid of that when they move to the real-time model. So basically, the Voxtral model is stronger than Whisper, primarily because its decoder is stronger. It's a more modern decoder from MiniStral instead of the decoder that was there in the original Whisper paper. But the encoder is the same, although it's adapted then to fit with the language decoder here. As I said, Voxtral in principle is not just a transcription model. It also supports text input. So you can ask questions of the audio and it will respond in text, or you can tune the model to just be transcription, or you can just use it with audio input only and not input any text. There's not a whole lot more I want to say here. I'll move and show you the paper now from Voxtral Real-Time. So the real-time model has to change quite a bit. And the way that these real-time models are trained is with a delay. You need at least some delay because you need to have context so that when I speak, the words will come out afterwards. Obviously, the words can't come out before I speak. So there has to be a minimum delay from when I say a word. And the way that Voxtral Real-Time is trained is with different values of that delay in increments that go up to about 2.5 seconds. And actually that information around the delay is injected into the text decoder layers through ADA norms. So you can see if I search here for ADA, yeah, an adaptive RMS norm, and it's enabling a single model to operate at any delay that is a multiple of 80 milliseconds. Actually, the QTI speech-to-text model has got, depending on the model size, there are two. The smaller model has a shorter delay, the longer one is a longer delay. But Voxtral Real-Time is trained to support different values of delay, which you can input at real time. The audio encoder is trained from scratch, I believe, in the case of Voxtral Real-Time, unlike in Voxtral, where it used the whisper encoder. And the decoder probably uses MiniStral. It's not clear. It's not clearly stated, but probably it's MiniStral as in the Voxtral model. But it's also got the addition of the information around the delay. So this is the real-time model, not supported just yet, but I'll plan to make a video about it when it does come out. And the nice thing about both the real-time and the Voxtral model is they already are supported by vLLM. So you're able to run a high throughput server if you want to run inference for either of those models. And that's a pretty nice feature because, for example, Whisper isn't supported with vLLM. You need to use something like cTranslate, which I talk about in my Whisper video. But it's always great to have vLLM because that means continuous batching. You can send in multiple parallel requests. I'm going to go through the training scripts very quickly. Nowadays with AI, there's not so much need to go through the code, but I'll give you kind of the highlights of what it takes to train. If you want those scripts, you can check out trelis.com/advanced-audio. There are scripts there for training many types of speech-to-text and also text-to-speech models. There's also now Trelis Studio, so you can just run training using this no-code platform. It's accessible via UI, but also via API. In fact, if you just go to the API view, and then if you open the skills file, you can take this skills file and just paste it into Claude Code, and then Claude Code will help you prepare data, train, evaluate, and deploy endpoints for your model. Now, you can also view the progress of that training that Claude Code is doing by looking at the dashboard. Just a note that before you get started, you should go to Settings and put in your Hugging Face token, and put in also Weights and Biases API key if you want to see the results coming out there. I'm just going to show you a quick training on Voxtral. You can, of course, use any other custom model that's supported. You can train Whisper, you can train Moonshine, and we'll be adding others soon. But here I'm just going to train on latent space dataset that I've prepared. It's some technical jargon from AI. And I'm just going to kick off that training job on the Voxtral mini model to see how this performs. It will all deploy on Modal. It'll inject the data, start the training. It will actually run evaluation on the base model beforehand and then on the fine-tuned model, so you can see that you've gotten improvements in performance. Now, I'll quickly show how these scripts work a little bit. It's not the exact scripts from Studio, but I'll show you the scripts that are in the advanced audio repo. For that, let me just go to my repo here. For those of you who buy it, when you buy it, you'll see it's advanced transcription. I might rename that, but it's what I mean by advanced audio. And here you can check out the README for Voxtral. You can basically just run this Voxtral Modal train script. I've been using Modal lately just because even though the prices are higher per unit of time, the spin-up time is way faster. So for doing short trainings, you can end up saving actually by using the spin-up, and it's just easier too. I save a lot of time. I won't go through the script in too much detail. I'll just highlight a few things. Learning rate here, 5e-5 seems to work fine. Lower rank in alpha at 32, fairly standard values here. The target modules being trained are these ones here. QKVEO, gate up and down, training linear layers in the MLPs and in the attention. I like to enable RS LoRa, and the audio tower is frozen. You could debatably unfreeze some and apply LoRa's there as well, but it's not done for now. Basically, the model is supported by transformers, so there's not a whole lot else to say. We can quickly check what's going on in the script. But you'll see that we have the model will be loaded using Voxtral for conditional generation. The data is collated. We run a baseline evaluation, and then we set up LoRa, just exactly as I said. And then we'll get the parameter efficient fine-tuning version of the model and set up the training arguments here. Then we'll create the trainer and push it up to hub. There's not a whole lot special to say because I'm not talking too much about data prep here. If you want to check out the data set, I think it's available on Hugging Face. It should be an open model. If I just go here. Yeah, you can see this is the data set that we're training on. It's a small data set of just 8 rows. And there's also a validation set available separately if you want to run. I'll actually make them public so that you can get access to them. Let me just make that one public. And I'll also make this one here public too. Oops, it was public. Okay, great. So back to check out where we are doing, you can see the evaluation has already happened. And we've got a word error rate of 7.6%. The training is underway now. It should be really fast because there's hardly any data. So you can see, yeah, the training should almost be done. Yeah, 100%. And it will run another evaluation and we'll see what the performance is. It will also push the model up to hub to the destination that you specify here. And when you're done, you'll be able to see the evaluation results. You'll be able to link to the model. You can link to inspect the evaluation results and listen to them and see the training logs as well. So for example, this was an earlier run I did, and you can see it just ran. I ran just with one evaluation row. You can listen to the audio and compare the base with the fine-tuned. I only fine-tuned on tiny rows, so the performance didn't actually change in that case. So it's now pushing this up to Hugging Face. It will then run evaluation and I'll be able to compare. So that's pretty much it for this video. If you have any questions on Voxtral, let me know. I recommend using this model in general, except if you need a very small model. So if you want something on device, you probably still need to think about Moonshine or maybe even the Whisper models. Whisper, although it's old, is just very well supported by libraries. But if you want a high quality model otherwise, I think Voxtral is a very good open source one. There's also Qwen ASR, which is good now, and I'll plan to do a video on that fairly soon as well. Cheers, folks.